Hey Dimitri, how are you tonight?
Pretty good.
Good.
How are you?
Good. Okay, so more sinusoid equations.
Yep.
Looks like they're not introducing a phase shift yet at this time. I don't see any questions on here. I see some phase shifts down here. And there, and there. So we'll look at the first few here and uh, see what we got here. Okay, so they want the amplitude, the period, and the vertical shift. Okay, so let's write our equation. A sine of bx plus d. So what's the easy one here? The vertical shift. How do we get the vertical shift d?
Um,
Max
oh yeah, my max minus the minimum over two,
plus
right?
minimum
Oh, it's plus.
plus the
So
minimum over 2. What's the maximum?
um 5?
What's the minimum?
-5.
What is d?
5.
What's 5 plus -5 divided by 2?
0?
Uh-huh. And if you
Okay.
look at that chart, I'm not doing any vertical shifts. That line of symmetry, the horizontal line of symmetry, is still the x-axis. Hasn't moved. In other words, on the next problem, there is a vertical shift, right?
Yeah.
But in this case, there isn't. So now we're down to y equals a sine of bx. Well, what's a? Remember, it's the
Uh,
opposite of that. It's maximum minus the minimum divided by 2.
right. So that's 5.
Okay, now we got this. Y equal 5 sine of bx. So we can solve for b, we'll be home free. What's b equal to in terms of the period?
Um,
Always have to do this translation. In other words, you always have to relate b to the period. And it's always 2 pi over the period. Or the period is 2 pi over b. Those mean the same thing.
right.
But in this case, we need to solve for b because they want the equation. So I got to look at the graph and what's the period?
Um,
In other words, you can read the period from the graph.
right. So 8.
Good. So the period is 8. So b is pi over 4. Now what's my final equation?
Y equals 5 sine uh 5 over 4. Thank you. X.
There you go. That's 0 vertical shift. It's got an amplitude of 5. And it's got a period of 8, which translates to a b of pi over 4. Okay?
All
Now
right.
let's do same thing on the next problem. Let's start with the d. I start there because to me that seems like it's the easiest thing to figure out.
Right. So it's so the maximum is -1/2.
Okay, so d is max plus min divided by 2. So -1/2 plus what?
Minus 3/2 over 2.
Okay.
So,
well, that's 2. Excuse me, that's minus 2. So we have
yeah.
minus 2 over 2, so we have a D of minus 1. And that's exactly how much we've shifted down vertically is 1 unit. That's minus 1 right there. Okay? So
Right.
that's how we're going to start, is with that vertical shift down. Okay? So D is minus 1. A?
Maximum minus the minimum. So, over D, or 2.
Be very
So,
careful here. There are a lot of negative signs. It's really easy to drop a negative sign.
it's 1 over 2.
Good. Okay. Only thing I got to solve for is B. Well, what's B equal to in terms of the period?
Pi, or, yeah, 2 pi over the period.
Correct. Reading the graph, what's the period? Now you can do this a couple of ways. You can go from there to there, but it's actually a little bit easier to read the values if I go from there to there. What is the period if I go from here to there?
4 pi over 3.
Correct. So B equals 2 pi divided by 4 pi over 3. You divide by fractions by flipping and multiplying. So that equals 6 over 4, which reduces to 3 over 2. I now have A, B, and D. What is my equation?
Y equals 1/2 sine of negative x.
B is what?
Oh, sorry. 3/2 x and then minus 1.
All right. Now, that's not a sine curve. What kind of curve is that? If I gave you this curve right here, that's a sine curve, right?
Yeah.
What if I give you this curve right here, the green one? What is that? That's a negative sine curve.
Yeah.
Well, what are we doing here? We are starting at the midpoint and going down. Sine curves don't do that. Sine curves start at the midpoint and go up. So we need a negative sign here. So our real answer, and the only way we can do that, we can either incorporate a phase shift to handle this, but the easiest way to do it is negative 1/2. In other words, when I figured out A, the only thing I was really figuring out was the absolute value of A. I wasn't figuring out whether A had to be positive or negative. In order to figure that out, you have to look at the curve. And you have to look at, well, what does it do from the origin? I mean, after I've vertically shifted it, it's not a sine curve, it's a negative sine curve.
Okay.
And it can be a negative cosine curve also. Now, if I am unsure as to whether or not I got it right, what can I do to make sure that this is a correct equation? In other words, they just have told you that your life depends on this being right. You're going to die if this isn't right. What would you do as a next step? How about we check some points?
Okay.
When I plug in x is 0, that's that point right there. What is y supposed to be?
-1.
Okay, so y of 0, I'll borrow from f of x notation here, is indeed, it's -1/2 times the sine of 3/2 times 0 minus 1. Well, that whole thing is 0, so -1, that point checks out. We really need to check out one other point, though, because that point would have been -1 whether I had a negative or a positive. So let's check out another point. We can tell that when I don't want to use 4/3 pi either. Let's use this point right there. What is that on the x-axis?
3 pi over 3, so pi.
Okay, so now let's figure out what y of pi is. Well, it's -1/2 times the sine of 3/2 pi minus 1, correct?
Yeah.
See what it needs to be. This whole thing better come out to be -1/2 or we do not have the correct equation. Well, what's the sine of 3/2 pi?
Here, hold on. I'll my
3 pi
calculator.
over 2, that's 270 degrees. So that is -1. So now we have -1/2 times -1, all -1. Well, -1 times -1/2 is +1/2. -1 gives us -1/2. That's our y value, -1/2. Now I'm pretty much ready to bet my life on it. In other words, I've checked 2 points. They both came out to be the same, and I made sure that I didn't just go down one period. In other words, if I had just solved for y of 2 pi, it wouldn't have showed me anything. I had still gotten that point right there. Okay? So
Okay.
I had to choose a second point to check out my equation that wasn't just one period removed. In other words, I'm looking at the curve. I know what y of 0 needs to be -1, it was, and I know that y of pi needs to be -1/2, and I can see that it is. So the minus sign was necessary. If I don't put that minus sign in there, then y of pi will not be -1/2. So I definitely need this minus sign. Now, it's perhaps not totally clear to you at this point why you would put it in there to begin with, but it all has to do with the appearance of that part of the curve. That is not a sine curve. That is a negative sine curve.
Okay.
Let me test you. Tell me what these are. What kind of curve is that?
Cosine. Negative cosine?
You got it. I think you understand it now. What is that?
Negative sign, I think.
Correct. And that's the closest thing we're looking at. When we look at that, I can see that part of it is negative sine. So if I'm not going to do a phase shift, then I have to have a negative sign in front of A.
Okay.
Now, I could do a phase shift. Now, how much have they taught you about phase shifts? Anything yet? In other words,
Yeah.
all of these questions, I do not believe, involve a phase shift unless this problem does. I haven't read it yet. Let's read that problem and see if they've introduced phase shift to you. All right, this is not going to involve a phase shift either. Okay, so for the moment, we can not talk about phase shifts. Even down here, it says identify the amplitude, the midline, the period, the domain, and range. Never mentions phase shift, and yet there's phase shifts everywhere. There's one there, one there, and one there. Interesting. All right. Well, at this point, I'm going to assume you have not learned about phase shift, and that's not part of the problems either. Okay? So let's do this word problem. These get easier the more practice you get with them. I was a little upset when they were giving you these the other day because I didn't think you're quite ready for that degree of difficulty with trig. But we've done enough work on the sinusoid function now that we should be able to do this. Remember what our natural sinusoid looks like.
Yep.
We'll just ignore the phase shift aspect of it. All right, what's A in this problem? Remember, it's maximum minus the minimum divided by 2.
Yep.
So what's the maximum? High point, 7 feet. Low point, 1 foot.
Okay.
What's max minus min?
6 divided by 2 is 3.
Okay, so A is 3. Now, B, actually, yeah, let's do B. We'll just do them in order. B is 2 pi over the period.
Yep.
What's the period here?
12.
Exactly 12. So the period is 12, so B equals pi over 6. Right?
Yep.
Okay. Now, D. We don't have a C, but D is the maximum plus the minimum divided by 2.
Okay, so 4.
What's our equation?
Y equals 3 sine of pi over 6 x plus 4.
Okay. Now, they didn't give us any information to know whether this is a positive sine curve or a negative sine curve. So I really kind of need to check out some points. They've really only given us 2 points, where time is 0, and incidentally, this shouldn't be x, it should be a t.
Oh, okay.
Because it's based in seconds. Okay? So when t is 0, what's the height of my water?
Zero.
Well, this whole thing would be 0
Oh, so 7?
before. Be 0 plus 4. but that's not right.
Okay.
Kind of gotten a little tricky with us here. Or have they? No, they haven't. So, if I was drawing a curve here, in other words, we've made a mistake. Let's see if we can figure out where. Okay? Well,
Okay.
this is the t-axis here. This is the height, the y-axis, the height of the water. And I know that when t is 0, the height has to be 7. So I got to start there. And I know that it goes from 7 to 1 over 6 hours. Well, there's 1. Here's 6 hours. I know the period is 12 hours. So it's going from 7 to 1. Like that. Oops, hold on, I didn't draw it quite right. It's going from, in other words, it's got to be there at 6. And that's beginning to look like
Cosine.
positive or negative?
Positive.
Ah, so it's not a sine curve at all. It's a cosine curve. Now,
Yep.
does that work? What's the cosine of 0? When t is 0, what's the cosine of 0?
1.
Times 3 plus 4 gives you that point right there, 7. Now let's check this point. Put in 6 for t. What do you get?
Oh. So cosine of pi over 6 times 6.
Okay. That's cosine of pi. What's cosine of pi?
Hold on.
Okay. Two things that you definitely want to memorize are how to draw a sine curve and how to draw a cosine curve. Okay, you just use it over and over and over. There's the sine curve, starts at 0, goes up to 1, goes back to 0, and then goes down to -1. Here's a cosine curve. Starts at 1, goes to 0, goes down to -1, goes back through 0, and goes back to +1.
Yep.
So what's the cosine of pi? That's where pi is, right there.
One.
It's -1.
Oh, no, pi. Yeah, -1.
Okay, so now if I plug in -1 times 3 plus 4, that gives me 1. That gives me the proper y value. So again, it wasn't just a question of figuring out A, B, and D. It was also a question of whether I should use sine or cosine or positive sine or negative sine or negative cosine. And you really have all 4 choices. The general standard is that you use whichever function does not require or requires the least phase shift. Well, if I use cosine here, I don't have any phase shift at all. If I were to use sine, I would need to put in a phase shift in there because I'm not looking at a sine curve. I'm looking at something that looks a lot more like a cosine curve. A positive cosine curve that's been vertically shifted up by 4 units. So that instead of going, well, I won't go any further. I think you get the picture.
Yeah.
Okay, So we've got our function. It's 3 cosine. Here, I don't want to erase it because I'm looking at it, but let's answer B. Those two, you got to memorize those two. Always. You should be able to create those from scratch from your head.
Okay.
Sine and the cosine curve. So here's our function. To answer A, what sinusoid function should be used? It's 3 cosine of pi over 6 t plus 4. Okay, so what's the amplitude of this? Question B, what's the amplitude? Okay, question C, what's the vertical shift?
Vertical shift is 4.
Down or up?
Up.
So it's up 4. Okay, what's the period of the sinusoid function that models the tides?
Um, 12.
Yeah, it's the starting point back to the same starting point, and that is 12. Notice that the low point came 6 hours after the high point, but one full period is the high point, low point, back to the high point, and that is 12 hours. So the period is 12 hours, right? Oh, I see. The question A was which sinusoid function should be used, and the answer is cosine. And the reason is that the cosine curve, if you draw a cosine curve, you start at the top, then you go down to the bottom, and then you come back to the top, which is exactly what the tides are doing. They're starting at the top. 7 feet is the high point. They're going down to the low point 6 hours later, and then they're coming back up to the high point. So that is why we're going to use a cosine curve, not a sine curve. Because cosine curves start at the high point, and then they go down to their low point. Sine curves don't do that. Sine curves start in the middle, then they go up to their high point, and they go back down to the middle, then down to the low point, and then back to the middle.
Right.
So depending on the action, whether you're talking about a Ferris wheel or tides, you need to know how it begins. Starting at 0. Am I starting at 0 going up? Am I starting at 0 going down? That's what determines whether you use sine or cosine. Now, question E is this. That's the answer to E. According to your model, determine the height at 5 p.m. So tell me what T is at 5 p.m.
Um, 5.
T is 0 at 8 a.m. And T is the number of hours. So what's the number of hours between 8 a.m. and 5 p.m.?
9.
Yeah. So they want to know this value right there at 9 hours. What is that value right there? Well, we're looking at the function. How am I going to figure out what that value is? Trying to figure out what the height of the water is, which is y, when T is 9. So just substitute. Start by substituting. Keep going. Tell me what to write next.
Pi over 6 times 9 Plus 4.
Okay. Now that's a number. We just have to figure out what it is. Okay. Well, that's 3 cosine of 3 pi over 2 plus 4. Here's the cosine curve. There's 3 pi over 2. 0. So what should the height be? That is 0. In other words, here's the cosine, starts out at 1. At pi over 2, it goes to 0. At pi, it goes to minus 1. At 3 pi over 2, it's back to 0. So substitute 0 for that. And tell me what the answer is.
4.
Correct. Just 4. In other words, that whole term disappears because through any number times 0 is 0. So the answer is 4. All right. Let me scroll down here. I can't scroll down anymore. That's okay. We'll answer 13 in the way that we should have answered the first one, which is to figure out whether we're going to use sine or cosine. So we have a buoy floating on the water, bobbing up and down a total of 6 feet. From the top of the wave, 3 feet above sea level, the buoy completes a full cycle every 12 seconds. Write an equation to represent the height of the buoy, and at t equals 0, it's the top of the wave. So the top of the wave means there.
So it's cosine.
Probably cosine, because sine doesn't start at the top. No part of sine starts at the top. Cosine can start at the top, or negative cosine can start at the bottom. But here, clearly at t equals 0, the buoy is at the top of the wave. So the action is going to look something like that. Okay?
Okay.
What's this height? What's the x or the t-axis height? 0.
Oh, yeah.
They don't give us any heights above sea level here. They're giving us sea level. This is sea level right there. And they're saying that when the buoy is at the peak, it's at 3 feet. When the buoy is at the base, it's got to be minus 3 feet. That's a difference of 6 feet between the top and the bottom that the buoy bobs up and down between. So this picture that I've drawn is relatively accurate. What is this right here?
That is 12.
12 seconds. One full cycle is 12 seconds. That is a full cycle there. Okay, so that's fairly straightforward. There's no vertical shift. There's no phase shift. There's an amplitude. What's the amplitude?
3.
So A is 3. What's B equal to?
So
2 pi over the period.
Here's 12. So it's pi over 6.
And D is 0. If this is our picture, and that's a great picture to use, you don't want a D of a number if you can use 0. So from this picture here, what's my equation?
Y equals 3 cosine pi over 6 times x.
Yeah, or times t.
Oh, yeah, t.
I actually prefer using x because it's not as confusing. When you use t, it looks like a plus sign too much. But the fact of the matter is that sinusoid functions are almost always in terms of time. Almost always. The horizontal axis is in time. That's why they're so valuable, is because there are so many periodic functions in the world, in the real world. Tides, breathing, Ferris wheel, I can name 100 different things that can be modeled by a sinusoid function or a cosine, but it doesn't have to be sine. Either cosine or sine is called a sinusoid function. Okay, so I think we answered everything. Amplitude was 3, period was pi over 6. We wrote the equation, used the equation to estimate the height of the boy at t equal 27.
So put 27 in for y.
Not for
Oh, wait.
Ah,
T.
no, you might be right. We're estimating a height. So y is what we're trying to solve for. So we're going to
Right.
put 27 in for t. So we have cosine of pi over 6 times 27. And that becomes 3 cosine. Let's see, if I divide top and bottom by 3, I get 9 pi over 2. Okay. Well, what's cosine of 9 pi over 2? That's an angle greater than 2 pi, correct?
Yes.
In other words, that is coterminal with some angle. Give me the angle inside the unit circle that's the same as 9 pi over 2. And the way you do it is you just keep subtracting 2 pi until you get something that's inside of 2 pi.
Okay. So let's see. Where's my use? Oh.
Don't look at your calculator yet. This is not a calculator problem.
So pi. So subtract 2 pi.
Keep subtracting 2 pi until you get to an angle that is inside the unit circle. That is, that's between 0 and 2 pi. Remember, all sinusoid functions that have a period of 2 pi are going to repeat. So the cosine of pi over 2 is the same as the cosine of 5 pi over 2, which is the same as the cosine of 9 pi over 2. In other words, I can always add 2 pi and it never changes the answer. So when they give me an angle that's outside of the 2 pi, I got to keep subtracting 2 pi's. Well, subtract 2 pi and keep doing it until you get an angle that's inside the unit circle.
Pi over 2.
And what is the cosine of pi over 2? Remember, cosine starts at its peak and then goes to the midpoint at the first break point, which is always pi over 2. So cosine of pi over 2 is 0.
Okay.
So the height of the wave at 27 seconds is 0. And I drew an extra couple of periods because that's what it is. 27 seconds is more than 2 periods away. In fact, they didn't draw enough periods. In other words, there's 1 period. There's the other period. It's this point right here. It's 27 on the horizontal axis. But it's 0 on the y-axis.
Okay.
All solved strictly by the equation, not by the picture. I'm not looking at the graph. I'm merely substituting 27 for t. into the sinusoid equation.
All right.
Now, let's look at these last few. I'm puzzled because I still don't see any questions. Okay, well, let's start with 13. What's the amplitude?
5.
What's the midline?
-6.
Good. What is the period?
So 2 pi over 3, right?
Uh-huh.
So that's it, 2 pi over 3.
Okay. What's the domain?
From
What can x go from where to where? What are its possible values?
-infinity to infinity.
Very good. What's the range? What's y going to go to? And this is a little tricky. What's the minimum and the maximum that is going to be? What's the maximum that can ever be? What's cosine go from? If I draw a cosine curve, what's that point and that point?
Oh, 1 and -1?
That's the maximum cosine can ever be is 1. The minimum it can ever be is -1. So if I want the range, let's figure out when this is -1, it's -5, -6. So that's the bottom end is -11 of the range. And when this is +1, it's 5 times 1, which is 5 minus 6. So this thing goes from -1 to -11 and all values in between. But it's impossible for it to ever be less than -1, and it's, for it to be -11, and it's impossible for it to ever be above -1.
Okay.
That's what you do, is you examine what is the range on those numbers right there. What's the maximum that can ever be? The second, number 14, what I got circled there.
1 and -1.
There you go. And that's going to allow you to figure out the range in the exact same way. Okay. So I think we actually did all of 13. Now let's do all of 14. What's the amplitude?
-2?
Just 2. Amplitude is this. Amplitude is the absolute value of A. So amplitude doesn't have the negative sign in front of it. It's a negative sine curve, and all that means is it's going to start down and then come back to the middle and go up. Like that.
Okay.
That's a negative sine curve. Okay. But to answer all these questions, A is 2. What's the midline?
9.
What's the period?
6 pi.
Good. What's the domain?
-infinity to infinity.
And what's the range?
So
To figure out the range, let that equal to +1. What do you get? Notice I don't have to worry about what's inside that, what I've circled, or what's inside the parentheses. I'm not solving for phase shift or anything. I'm just trying to figure out what is the greatest possible value that the sine of any angle can have.
So that's 7.
Correct. What's the smallest? Or what's the other end of the range?
11.
So the range is from a 7 to 11. And it's with brackets. If I'm putting the range out like that, because it can be equal to 7 and it can be equal to 11. So you wouldn't use parentheses. Even if you're doing interval notation, you would use a bracket. That's the range right there.
Okay.
And we're going to do the same thing for this last one. Amplitude.
1/2.
Midline.
2.
Period.
2.
Domain.
-infinity to infinity.
And range.
All right, so if that's 1, then 1 times 1/2 is 1/2 plus 2 is 2 and 1/2. So 2 and 2.5, 2.5.
That's one end of the range.
And then
that was when this is -1.
Yeah.
Notice. So what about
one,
+1?
1 times -1/2 is -1/2 plus 2. So that's just 1 and 1/2.
So the range is 1.5 to 2.5. Now, I want to say one thing only here. There are actually a couple of different formats for this thing. And it's very important. Not so much for you at this point, it isn't. It makes a difference if that B is inside the parentheses. In other words, about half the schools in Colorado use the top format, and the other half use this format. Notice the difference. And there's a pretty big difference. If I'm using this format, the period is still 2 pi over b, but c is my phase shift. C is my horizontal shift. If I'm using this format, well, b is the same. My period is still 2 pi over b, but my phase shift isn't the same. That's not, c is not the phase shift in my second equation. I got to factor the b out. How do I do that? I put it outside the parentheses, and now that becomes the phase shift. Phase shift is now that if my b was inside the parentheses. Now, it's hard to say which one they're using. I'm inclined to believe they're using this one for you. And it's a little hard to tell because they use double parentheses in all of these, but as they should. But notice the B is outside the inside parentheses. That 1/3 is outside the inside parentheses. That pi is outside the inside parentheses. So I'm inclined to think we're using this format right here all the time. And like I said, it doesn't really matter for you in these problems because they haven't introduced phase shift yet. If you're not talking about phase shift, well, then that is the same as that. In other words, if there is no C, then it doesn't really matter whether that B is inside the parentheses or outside. But down here in all of these problems, they do have a phase shift. And the B is outside the parentheses. So all of these problems, you would use that format right there. Only there would be a -C. and that C is the phase shift. In other words, on 13, the phase shift is pi over 7 to the right. On 14, the phase shift is minus pi over 10 to the left. And on 15, the phase shift is minus 1/9 to the left. That's how phase shift works. Phase shift is exactly the same as horizontal shift.
Okay.
Okay? And you may or may not get into it. This might be as tough as you get in trig. They may not want to introduce the concept of phase shift to you yet. It does complicate things considerably because it brings into question whether the B is inside or outside the parentheses. And they could give it to you either way. In other words, I could give you an equation that's this. If I gave you this as your equation, well, B is 2, but the phase shift is not pi over 2. I got to factor out that 2 to get it on that side of the equation. And in order to do that, it turns that into pi over 4. So the phase shift is pi over 4. So it depends on whether that B is inside or outside the parentheses as to what your horizontal shift is.
All right.
Okay. You good to go for tonight?
Yep, that's it.
I think it feels to me like you're getting this, especially without the phase shift. Without the phase shift, everything is fairly straightforward. Once you figure out whether you want to use sine or cosine, and that's all determined as to whether the thing starts, goes up, starts and goes down, those kind of things.
Okay.
All right, Dimitri, I'll let you go. I'll talk to you next time, I guess next Tuesday.
Yes. All right.
Have a good one. Bye-bye.
Yep.